All right, we're on the last part, and sorry, the bell's about to ring, so I think they'll be loud behind me in a second, but numbers 8, 9, and 10, we're going back to transformations. In number 8, when we're rotating 90 degrees clockwise, so just remember, like if this is 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, that clockwise, something over here, the hands of the clock would go like in that direction. So, of course, you can actually rotate your paper and do it that way like we did in class. But remember, anytime we do a 90-degree rotation, the X and Y values switch places. So if I write down the coordinates of A right now, A is at -1, 2, 3, 4. So A is at -4, comma, 6. When I bring it into this quadrant, the X's and Y's are going to switch. So instead of going over 4, I'm going to go over 6. If I think about this quadrant, which is quadrant 1, everything in this quadrant is positive. So I have positive X's and positive Y's in that quadrant. So A prime is going to be at +6, +4. So if I go over here and graph it, I'm at 6, 1, 2, 3, 4, and that's A prime. Okay, so I could do the same with B. If B is at -2, 4 right now, if those are my coordinates for B, B prime is going to be at 4, 2. So I just switch them. I switch the X and the Y, and then I could think, well, hey, because I'm going to this quadrant where everything's positive, it's the 2 that changes from negative to positive. So there's my B prime. And then lastly, my C is currently at -5, 2. So when I switch those, my C prime will be at 2, 5. So I go over to 2, 1, 2, 3, 4, 5, and that is my C prime. And if you're doing this on paper where you rotate your paper instead, you should get the same thing regardless. All right, number 9, we're doing a dilation. And the good news is we are dilating from a center that is at the origin at 0, 0. So luckily, when we do that type of dilation, I guess I could just erase this from last video. When we do that type of dilation, we can always multiply our X and Y coordinates by our scale factor. And just keep in mind that when you multiply by 1/2, that's the same as just dividing by 2. All right, so if I write down my coordinates, if A is originally at, let's see, 1, 2, 3, 4, -4, 6. If I divide both of those numbers by 2 or multiply by 1/2, A prime is going to be at -2, 3. So I can go over 2, up 1, 2, 3, and there's going to be A prime. If B is currently at 2, -2. Sorry, so B is currently at -2, 4. B prime, again, I'm going to just divide those by 2 or multiply by 1/2, should be -1, 2. So -1, 2, there's my B prime. And then if C is at 1, 2, 3, 4, are we at a 5? 1, 2, 3, 4, 5. So if C is currently at -5, 2, when I divide that by 2, I'm going to get a -2.5 or 2.5, 1. So I'm going to go over 1, 2, and then a half, and up 1, and I'm going to put my, sorry, my pen is being funny. I'm going to put my point right there, and that's going to be my C prime. And then we get this cute little triangle when we do that. So that is our transformation. Okay, number 10, we are translating using this translation rule. So I can either interpret this as that I'm going to the right 8 units and then I'm going down 7. So remember, you travel left, right along the x-axis, up, down along the y. Or I could actually literally plug those points in there to do the translation. I think this way is probably easier. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And then down 1, 2, 3, 4, 5, 6, 7. All right, so that's my A prime. I can do the same with each point, Or I could say to get from A to B, I go right 2, down 2. So to get from A prime to B prime, right 2, down 2. And I can only do this with the translation. And then to get from B to C, I go down to left 3. So B prime down to left 3 puts me at C prime. And no matter how you do it, that is how it should look. All right, the very last question. Oh, we've done so many like this in our triangles unit. Find the values of A, B, and C. So keep in mind that the sum has to be 180 inside each triangle. So angle A plus 60 degrees plus 47 degrees must add up to 180. So I could combine these terms and say that A plus 107 has to equal 180. And then when I subtract my 107 from both sides, A equals, let's see, 80 minus 7 is 73. So that's got to be 73 degrees. Is that too loud? No, you're fine. And then we have a linear pair here. Or I could think of B as being the exterior angle. So it's going to be the sum of these two angles. So if no matter how I think about it, if I think of the linear pair, 180 minus 73 should give us B. So for B, we should actually get 107. And then lastly, to find angle C, I might just come back and use this triangle. If that's 107 degrees, I know that 52 plus 107 plus C must add up to 180. So when I add these together, 107, 109, 159 plus C equals 180. I hope I'm doing this math right in my head. Subtract that from each side. So C equals 180 minus 159. And let's see, I'm going to borrow from my 8, make that a 10. 10 minus 9 is 1. 7 minus 5 is 2. We should get 21, unless I made a mistake, in which case, please let me know. All right, that's it. I think you've got one more question to answer on Schoology, and don't forget to submit this so that you've got it all done. Hey, have a good one.